Hello, everyone, and welcome to today's Safety and Health webcast, Demystifying the Selection, Use, Care, and Maintenance of FR/AR Clothing, sponsored by Bulwark. This is Alan Ferguson, Associate Editor at Safety and Health magazine. I am moderating today's session in place of Barry Bettino. Thank you all for joining us. We're going to start the presentation in a couple of minutes, but first I want to go over some preliminary items. The views of today's speakers and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or magazine endorses those items. At the end of today's webcast, we will conduct a question and answer session. To ask a question, simply type it in the text box in the lower left-hand corner of your screen and click the button for Submit Question. Feel free to ask your question anytime during the presentation. You don't have to wait for the Q&A to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded to today's speaker. At the end of the webcast, you will be asked to complete a brief evaluation survey. I will let you know more about that after this presentation. This webcast is archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. Finally, if you need basic troubleshooting information, click the Help button located on your screen. With that, let's go ahead and get started. Our speaker today is Derek Sang, Technical Training Manager at Bulwark. Derek has worked in the FR clothing industry in a variety of roles for more than 20 years. He has also conducted more than 250 educational seminars on the hazards of arc flash and flash fire, and developed more than 40 hours of training curriculum for Bulwark University covering all aspects of FR clothing. Derek, whenever you're ready, go ahead and take it away.
Alan, thank you very much for that kind introduction, and welcome everyone. Good morning and or good afternoon, depending on where you're listening to us, and thank you for taking time out of your day to listen to our webinar. So let's get started. The first slide up on the screen, hopefully everybody's had a chance to read. That's our disclaimer. This presentation today is for informational purposes only. Obviously, as employers, you are responsible for your risk hazard assessment, and we can make no claims today on how our apparel will interact with your hazards based on this presentation. So good, the attorneys are taken care of. Let's move on. As Alan said, demystifying the selection, use, care, and maintenance of flame-resistant arc-rated clothing. Take all the brands out of the equation, all the fabrics out of the equation. This is probably the number one thing that we get asked on a regular basis. How do I select this stuff from everything that's out there? And then once I've got it, how do I use it properly, care for it properly, and maintain it? So we're going to touch a little bit on that today. Obviously, in 45 minutes, we can't get really deep into it, but this will give you a good general idea of things to look for when putting together and maintaining that flame-resistant arc-rated clothing program. So, quick summary, these are our hazards. Secondary protective apparel is used primarily to protect against arc flashes, high intensity, short duration, and flash fires. Lower intensity and longer in duration, and a little bit of molten metal splash in our ferrous and non-ferrous industries that way. So that's our cores. The proper selection of PPE is extremely important. Even though the thermal hazards that we're talking about today are going to differ, the test methodologies on evaluating those fabrics for those hazards are different. There is a lot of overlap, especially when it comes to the basic selection, use, care, and maintenance of those garments. So that's what we're going to focus on today. We're going to look at the regulations, the standards, and best practices. So first, if there's a law that gives us some insight into what we should be doing, we'll talk about that. If there's standards, things that we should be doing to comply with the law, we'll talk about that. And then in some cases, there's neither, but there are some really good best practices. I mean, we look at what we've been doing at Bulwark for over 40 plus years. We have some good information, as well as does the rest of the marketplace as kind of subject matter experts on what we should be doing. So that's what our goal is today. So what are the basics? Well, first and foremost, if you look at the general duty clause, the basic relationship I enter in with my employer as an employee is they will not hurt, maim, or kill me on the job. That being said, how does that employer ensure that that doesn't happen? They're required to do a hazard assessment. Well, some hazard assessments are real easy. Stuff falling from height and can hit me on the head, I get a hard hat. If there's stuff spinning around in the air and can go in my eyes, I get safety glasses. And over 185 decibels on the job floor, what do I get? Hearing protection. Well, if dust can ignite, vapors can ignite, if a 200 amp disconnect can explode, ignite, and that ignition can potentially ignite my regular work clothing, I'm going to replace that work clothing with garments that have flame resistant properties. They will put themselves out when that thermal source is removed. So choosing the right PPE for the job. Remember, the law says you shall protect your people. Well, that being said, how do I do that? Well, we look to our standards, and we have some really good standards when it comes to arc flash and flash fires. NFPA 70E for our arc flash and general industry, NFPA 2113 for our flash fire hazards in those environments. And then we have, in North America, we have our Canadian counterparts, DSGB 155 for flash fire, and our Z462 for arc flash. So those are our standards. That's our reference point. So as I said, oil and gas is great. We have two really good standards. Now, everybody who has that hazard is probably familiar with NFPA 2112, and they want to have NFPA 2112 compliant garments, but the real standard that safety director wants to have on his desk and wants to refer to is the sister document, NFPA 2113. That is the standard for how to utilize 2112 garments in their environment, how to do your hazard assessment, how to specify the garments, and ultimately how to train folks on to proper donning, doffing, etc. So that's where 2113 and 2112 come into for flash fire hazards. In our general industry, we have NFPA 70E. Now, that's a pretty deep document. There are whole seminars. There's multiple days of training on 70E. 70E is primarily to help electricians not get shocked when working on energized equipment. The other hazard they cover, obviously, is arc flash. So in respect of time here today, what is the most basic, simple thing you can take away from 70E? What's the relationship? The incident energy, when you have failure, when you have an arc flash and you determine the incident energy, how much energy is coming out of that equipment that failed, that's measured in calories per centimeter squared. We have arc-rated clothing. That arc-rated clothing typically is going to have calories per centimeter squared, either expressed as an ATPV or an E sub BT. You want to have more arc rating than incident energy coming out. So if you have 5 calories coming out of that box, you want to have 6 or more calories in your arc rating. That's the relationship there. In our utilities, okay, we have a law. We have 1910-269, and that law states that you will specify arc-rated clothing that is equal to or greater than a reasonable estimate of the incident energy your employee could be exposed to. So you have to use one of these calculation methods to determine a reasonable estimate of all the equipment that your electrical workers will be interacting with, and they need to know that in order to wear more arc rating than incident energy they could be exposed to. And that's the law there for our utility side. So as we're starting this evaluation process, what are some of the things that we can look to? Well, the easiest place to start, and trust me, it's not 100%, but the easiest place to start is look at labels. Labels are a good way to understand kind of the resume, the pedigree of that garment. We are required to, as manufacturers, to give you a lot of information. For example, ASTM F1506 requires that we communicate all this information to you regarding the arc rating, the performance of that fabric and that garment in an arc flash. So that's a good place to start. For our flash fire hazards, we have similar requirements. In NFPA 2112, we also have to notify you of all this information on how that garment got to be independently certified to be NFPA 2112 compliant. So there's all that information. Again, great place to start. The downside is, though, there are weaknesses in that evaluation method. Why? There are some folks who play loose with what those labels are required to do. They replicate other people's logos to give you the impression that they're meeting a certain requirement when they're not. In some cases, they flat out can't communicate at all. In this particular example, I don't know if you can see at the top based on the side, but if you read that garment is flame resistant. Now, that would be a great knockout for me as a Q&A guy. I'm going to go through and go, wow, that label doesn't even meet the requirements of spelling. So I don't know what flam is. I'm glad it's resistant to it, but that should be an absolute knockout. So again, good place to start with our labels. Not necessarily infallible or 100% foolproof, but a good place to start. So again, we have a poll here, just real quick. Labels can often be misleading, and what should you look for your FR/AR product is NFPA 2112 approved. One answer is indicate that they meet performance testing and labeling standards and regulations, correctly list the regulations and standards garments are required to meet. They indicate the garments have been certified by a third party, all of the above, or not sure. So I'll give you a couple seconds, filter through that, and if you'd be so kind to click one of those. I can click this button and hopefully share the feedback with you. There we go. Well, we have a very, very strong FRIQ in our audience today, and everybody nailed that one. Great job. So moving forward, training. Now, if there's one part of the selection, use, care, and maintenance that we find is a struggle with our end user community, it is training. And we find that a lot of folks kind of don't understand where FR clothing falls into training. They kind of miss that FR clothing is in fact PPE, and under 1910-132, which is the law, we have to train our people when it comes to PPE, document that training when it comes to PPE, and we even have some of our standards that go a little bit deeper into what that training should look like when it comes to flame-resistant arc-rated clothing. So as I mentioned, we have a law that says, hey, the employer shall provide training to each employee who is required by this section to use PPE. Each such employee shall be trained to know at least the following, and this is key. When PPE is necessary, what are you protecting them against, and why are they wearing this stuff? What PPE is necessary, okay? And then for us, because we're dealing with apparel, we have to train them how to properly don, that's our fancy way of saying put it on, doff, again, our fancy way of saying take it off, adjust it appropriately, and in our case, it's zipped up, buttoned up, sleeves rolled down, cuffs enclosed, shirts tucked into pants, coveralls zipped up. All those things have to be addressed. The other part that's key to this is you are not impervious to injury because you are wearing flame-resistant arc-rated clothing. There is limitations to all PPE, but especially when it comes to shirts, pants, and coveralls going into thermal hazard or more being accidentally exposed to a thermal hazard. What are the limitations of this PPE? How can I be hurt? What is it good for? What isn't it good for? What are my expectations? What should I know? Because we definitely don't want to give the impression that we can run into burning buildings and start saving babies because we're wearing a 7-ounce flame-resistant arc-rated coverall. Then the proper care and maintenance and the useful life and how to properly dispose of PPE when you need to retire it. One of the most commonly cited regulations during the oil and gas drilling boom of the 2012, 2013, and into 14 was improper care and maintenance of flame-resistant clothing. It was very easy, and it wasn't uncommon for a citation officer to go into the drilling environment and say, how many FRCs do you have? And the employee would say, well, I have 3. And then the follow-up question, well, how many days are you working? They would say 6 or 7 days. You can't properly care and maintain 3 coveralls in a 6-day work week. So that was an easy citation. We saw other things like rig wash being used and other areas of where this was easy for folks to go in and cite improper care and maintenance of PPE. The big piece that we see more common today where there's a little bit of a gap is documentation. So first, we have to have the employee who's affected by the PPE has to demonstrate an understanding of the training specified in the paragraph and his ability to properly do what is being asked for him, and then we have to document that, and we have to file it, and we have to be able to show someone that they've indeed been trained on their PPE. And for some reason, when it comes to, again, shirts, pants, and coveralls, we don't necessarily follow all the way through on that. So let's do a better job of that. Implementation, this is the other key piece. Now that we've got this stuff, and now that we're putting it out into the field, what is proper implementation? Because you can have the best PPE on the planet, you can have invested tons and tons of money on your PPE, and at the end of the day, if you don't implement it properly, you basically wasted that investment. If you've got your hard hat tucked underneath your arm and it looks more like a lunchbox than a hard hat, that's not proper implementation, and you're going to get hurt because you're not wearing your hard hat. If your safety glasses are tipped up on top of your head, or your earplugs, then we see them all the time hanging around your neck like a necklace, we have the PPE, but we're not properly implemented. Same goes with our FR clothing. So I always get asked from my safety professionals, point me to where it says how they have to wear it. We have that information. All our standards tell you how to properly wear the PPE. The law says you have to protect your people. Your standards tell you how, and in the standards it tells you how to wear it. For example, in 2113 it states that the workers must stay buttoned, rolled, and tucked. It also gives you guidance on undergarments. It gives you guidance on what you can wear underneath, because you just can't wear anything underneath. So our standards talk to these challenges and they give you direction. In 70E, same thing. The correct use of arc-rated PPE in general was updated in 2012 to include direction on they have to fit correctly, they have to be appropriate for freedom of movement, sleeves must be fastened at the wrist, shirts must be tucked in, and that shirts, jackets, and cover will be closed up to the neck. Now, it doesn't say top button, it doesn't give you specific direction like that, but it says up to the neck, because obviously closing that top closure can be difficult for some, but remember, we're using our hard hat, we've got our face shield, we've got our chin cup, we've got our instructions to keep our chin tucked in, which brings that chin cup down lower. We're protecting that area, but it's essential that we close up to the neck. And again, it also talks about undergarments and what you're allowed to wear underneath, and we'll talk about that shortly. In our electric utilities, our standards tell us also what we could do. Now, this is probably the vaguest of the three as far as giving direction, but it tells you that clothing should cover potentially all exposed areas completely as practical, and they should be properly interfaced. Well, you ask anybody in a garment, proper interfacing of a shirt and pant is the shirt tucked into the pant. That is proper interfacing. Now, I would much like to see that stronger language. I would like to see it adopt more of the 70E application, telling people to tuck in, because we know from experience that if you leave your shirt untucked, arc flashes that go down, hit the ground. What's the law of thermodynamics? Hot air rises. We are going to have all that hot, energized air coming up, lifting up our garments and exposing typically lightweight cotton undergarments to tons of thermal energy. and you've got a chance for ignition because your garment's not properly interfaced. So we do have some help in communicating to our force, our team, that they need to roll the sleeves down, they need to tuck the shirts in, and they need to button them up. As I mentioned in the tail of those standards, all the standards talk about layering. So what are you allowed to wear under your FR? Most people understand today that the common answer you'll get, the hands will all raise and they'll say, cotton, cotton. They're correct. Okay? Your options are cotton, wool, silk. Those are all natural fibers. They will not melt and drip. That's what's key for the underlayer. Or don't wear anything at all. Then there's nothing going to melt or drip. Now, what's the challenge there? Well, the challenge is when you have break open, when you have fabric failure of that outer layer. In our utilities, we say if you're going to wear natural fibers underneath, you have to make sure that that outer layer has more than enough protection not to have break open, exposing that non-ARC rated or non-FR undergarment. So what happens when we do have break open? You're exposing potentially something that's ignitable to energy. If there's enough energy left over, if there's enough to potentially ignite that, that is a concern. So how do you eliminate that? That's when we look at flame-resistant ARC-rated base layers. That additional layer of protection is better. How much better? It depends on what you want to achieve. For our oil and gas folks, 2 layers of FR are better than 1 layer. For our arc flash protection folks, if you're looking to achieve a systematic goal, meaning that you want to get the combined protection of those layers, there's some key things that you need to do, and we'll talk about that shortly. But understand that 2 layers of FR are better than 1 or 1 and a layer of non-FR. Also, it eliminates the need for the underwear police. Think about it. I'm a safety guy, and I've done all this training, and we've invested all this money in our ARC-rated clothing program. And at my tailgates and at my meetings, I see my members, my teammates, and I can see from their calls, they all have that tiny little white triangle. And in my mind, I'm going, they were paying attention. They're all wearing 100% cotton T-shirts. I've done a good job. I pat myself on the back. Here's the challenge. Of all those little white triangles you see at the neckline of your employees, are you 100% sure that they're 100% non-FR cotton? Can you get white T-shirts that are 80-20, 60-40, 50-50? The easy answer is yes, you can. So you technically could be looking at a sea of white triangles with all different fiber combinations, and some of them are potentially meltables. That is a challenge. So who are you going to say has to go and check all those necklines that are indeed 100% cotton? The way to eliminate that and give ultimate peace of mind is go to an FR/AR base layer. All the top manufacturers of base layers will have some identifier. This one just happens to be a Bulwark triangle. You see the Dry Fire Dragon. You see the Carhartt emblem. You see all the top manufacturers are going to have their logo in that neckline. So at a scan, you can see that you have that base layer there. So you eliminate that. Because meltable undergarments are a real threat. Unfortunately, this young electrician is going to carry the scars of his 100% polyester performance fabric for the rest of his life. His outer layer, his ARC-rated shirt held up just fine to that incident energy. The problem was all that radiant heat, all that oil, it immediately hit that lightweight 100% polyester, melting it. And then remember, arc flash, what's the big thing you have? Concussive force. That's 2,200 square foot-pounds of force driving that molten plastic into the skin. That's at least 30 to 45 days in a burn unit being deburred from that plastic injury there. And that mistake that took a quarter of a second was going to be carried for the rest of his days. He'll be reminded of that mistake and that he chose, either because he wasn't trained or he ignored it or it was a hot day and this stuff keeps me cool and it helps me when I sweat. Whatever the rationale is, that mistake's going to be carried for many years to come. There's lots of folks doing a lot of work on layering. Layering combinations for increased arc flash performance are very common nature now. The tough thing is when you have competitive fabrics, for example, Bulwark over Carhartt or Carhartt over Bulwark over whatever combination, those aren't as readily available as the manufacturer over the manufacturer. So you may have to do some research. If some of your layering options are exotic, you may have to go and empower a third party and have them go perform the testing so that you can know exactly what the combined arc rating is, because in order to utilize it, you have to know what it is tested together. So which base layer is correct for you? Your hazard assessment is going to tell you, and your ultimate goal of what those base layer combinations want to be will tell you. Like I said, for our flash fire guys who are just looking to eliminate anything that's meltable or ignitable underneath what they're wearing, short sleeves, that works fine for them because their hazard is not measured the same way as we do in arc flash. Now, for our arc flash folks, whether that is an NFPA 70E general industry requirement or our utility guys, if you are looking to utilize the combined performance of those two fabrics, for example, I'm going to take the base layer, which is a 5 calories of protection. My outer layer is 8 calories of protection. When I test them together, I now have 24 calories of protection. My jeans are going to be 14 calories. That tells me that that combination that I'm wearing based on my other PPE, I could potentially work on equipment that is 14 calories or less. Because remember, even though my upper torso is 24, don't forget your lower. Your system is your lowest ATPV. So that 5 and 8, when tested, is 24, but your denim, your jeans are 14. That means you can work on 14 or less. If you wear the short sleeve, and I give you the same numbers, outer layer is 8, base layer is 5, denim is 14, what is your system? Your system is 8 because you are unprotected from mid-bicep to wrist. That's your lowest ATPV, is that single layer, so you don't get the benefit of the system. So in order to have the system benefit, it has to be long sleeve. If you just want the protection of an additional layer, then know that you're still what your outer layer is. You're still that shirt weight. You're still that 8 calories, but you have more protection because you don't have to be concerned about a non-FR 100% cotton base layer. So hopefully that makes sense. And if you want any more information on layering, definitely get a hold of me on that, because that is a subject within and on itself. So now we get into the do's and don'ts. Here's some pictures of do's. For our coverall wearing folks, this is how you properly implement a coverall in the field. Now, the one in the middle is a premium coverall. It has the extension of what's called a mandarin collar. As you can see, that's very race car, NASCAR, IndyCar influence. You can actually roll that collar down flat and also roll it up to the mandarin style that it is for additional neck protection if needed. But a non-premium coverall that doesn't have that functionality is just as fine. On the right that you see there, that is rolled down, that is zipped up, and that's how you properly implement a coverall in the field. That being said, this is what we see a lot of the time in the field. We go on break, it's hot out. We go on lunch, it's hot out. We go from the plant floor to the break room. We do that stopping to where we take our coverall halfway down, tie our sleeves around the middle, and we forget when we go back into the hazard that it's tied around our waist. That doesn't happen as often, but we do see it. We see a lot of what we have in the middle. We have unzipped, that's well below up to the neck. We've rolled our sleeves up because it's hot and uncomfortable, and this is how we're going to go about our workday because it's not going to happen to me. The other one you see there is our friend duct tape. Remember, duct tape is not an alteration method. It is not a repair method. and it's not a temporary gaiter, as you see in this case. That is meltable, ignitable, and we don't put anything like that on our FR clothing. Into our shirt and pant world. Here's what you should look like in shirts and pants. So what you have here in the middle is proper implementation. We've expanded it so you can see that it's properly tucked in. Now, you can easily make the argument that the snapshot there is not buttoned to the neck. We unbuttoned that one button so you can see that he's wearing an additional layer of FR, so exposing the logo. I would like to see that second button there done up, and we'd be good to go from there. Some don'ts. Now, in my utility world, guys, I'm sorry to call you out here on the phone. I see this a lot. I see the one in the middle a lot of the time, especially in the hotter months. Standard protocol seems to be untucked a lot of the time. Not so much unbuttoned in some cases, but we do see that happen on the far right. Now, what I want you to think about is this one. On the two close-ups, in shots there on the left, what you wear on your head can jeopardize a very good ARC-rated FR clothing program. If you happen to wear non-FR bandanas, non-FR beanies, non-FR stocking caps, non-FR ball caps, if you're wearing stuff under your hard hat in cold months, hot months, whatever the case may be, if that is non-FR, that is potentially ignitable and or worst case, meltable. You do not want to have anything that can melt onto your head. Your brain is very susceptible to changes in just small amounts of temperature, fair or less melting hot plastic or having something ignite underneath your hard hat and cause injury to that area. It could easily, and we've seen fatalities occur because of the damage that thermal energy does and the swelling that's caused in the brain, even though their ARC-rated FR clothing program worked just fine. So that's a place that you've got to be cautious of when you're training your folks on what they can and cannot do in the field. The one on top of that is equally as concerning. That is a very good ARC-rated FR jacket, very expensive in many cases, will do the job, has tons of protection. It will keep you warm, okay, and it'll also protect you. What's my concern here? My concern is, what is that hoodie made of? Because the second it pops out over that jacket is now the outermost layer. What do your law, regulations, and standards say? The outermost layer must be ARC-rated or flame-resistant at the very least. And do we know that to be true with that garment? If that's 100% cotton or some combination of, and it's ignitable, that's a whole ton of fuel you just put on the back of your neck. Forget about the chance that it's potentially a hang-up challenge if you're climbing or moving around in confined area. Forget that for a second, but just think about what a huge chunk of fuel that is sticking out of your perfectly good flame-resistant ARC-rated clothing. So again, just areas that we see folks to where caution needs to be applied. So again, safety always, button tucked and rolled. Make sure that we're implementing that philosophy at all times. These are accidental events. If we knew there was going to be an arc flash or a flash fire, guess what? We wouldn't be there. We definitely wouldn't be rushing to tuck in our shirts and pants and button them up. We wouldn't be there. They're accidental for a reason. Okay, this is secondary protective apparel. It's designed to be worn all the time and worn properly, or it's not going to protect you as well as it could. Picture that you see there to the left. This electrician failed to do one thing. And if there's electricians in the audience, I'm sure you're probably thinking out loud and know exactly what happened. Because why? He took his PP off and he rolled his perfectly good ARC-rated shirt up. You can see mid-bicep there where it started working, because that's where he rolled it up to. He took off his rubbers and leathers, and he went on to doing what he thought was a de-energized task. He thought he had done all the steps except for one. He failed to verify that he had indeed de-energized the equipment. And when he went to put that tool in the equipment, it obviously arced. That is a career-ending injury. You've got second and third degree burns there. The cost of that is astronomical. It's career-ending. You will not turn a screwdriver again with those kinds of injuries. The aftermath shots 2-3 days later are horrific. Amputations are involved, and it all didn't need to happen, but we made a mistake, and in a blink of an eye, a career is over. It is forever changed. So now that you've got all this stuff, now you're implementing it properly in the field. How do you care and maintain this investment? And depending on, it can be anywhere from $800 to $1,800 a person that you are maintaining on an annual basis, depending on how deep and wide you get your FR/AR clothing. So all the standards, going back to the standards, the best practices, what they tell you, follow the manufacturer's instructions. The manufacturers tell you on all those cavalcade of labels that we put on those garments that give you tons of information. One of the pieces of information we give you is how to properly care and maintain your garments. Turn them inside out. Don't use bleach. Don't use chlorines. Wash them with light garments. There's a myriad of things that you can do that we lay out for you, so it's easily done. If you don't want that or you don't know where to find it, you can always go to the company's website. All the top manufacturers have their care and maintenance stuff that you can download in PDF, and it's easily accessible. So knowing what to do should be quite easy. In today's world, with quality, and this is the key, what is quality FR? Quality FR/AR clothing today is very, very hard to mess up. Now, can you take the stuff home and clean it? Absolutely. Can you use an industrial laundry to clean it? Absolutely. If you've got stuff that you don't want your employees taking home to their families and they're in and around it, yes, by all means, utilize those. If you want to streamline your pickup and delivery and that, by all means, use those. You can also, based on logistics and based on costs and based on everything else, you can take the stuff home and follow a few simple steps, some good common sense stuff, and easily take care of this, assuming that you've done your homework and you've got good quality flame-resistant garments. Simple things like don't use bleach or peroxide. Peroxide is a sneaky one today because that's OxyClean. Don't use that stuff in there. You're weakening fibers. Fibers are your protection. You don't want to do stuff to weaken them. Don't use fabric softener. Fabric softener is an accelerant that includes dryer sheets and in the liquid form. Don't put an accelerant on stuff that could potentially be protecting you in a thermal event. Wash them separately. We talked about keep your work clothing away from your kids' clothing. That's, again, common sense stuff. Don't over dry. Don't over anything on it. Again, easy stuff to do. It'll last you a long time, maximizing your investment. So in this picture here, the easy one right there, there's the arrow. Don't use OxyClean. Don't use liquid fabric softeners. Don't use chlorine. Don't use starch. And don't use dryer sheets. Just good old plain liquid detergent. Boom, off you go. Now, it's not as easy as that in the big picture. That sounds relatively simple. There are a few caveats you got to remember, especially in our summer months when we've got vector-borne diseases now becoming prevalent. You've got West Nile, you've got Zika, you've got ticks, you've got all this stuff. Be very, very cautious. DEET is an accelerant, both in the dry form and the wet form. Do not spray that on your clothing. There's a lot of good FR-safe products out there today. A little bit of homework, a little bit of guidance. You can find some stuff that they can put on their garments. The DEET folks will tell you to put it directly on the skin, wear it that way, utilize those things. And again, vector-borne diseases are very tough, and we need to be countering those. But just please don't be soaking yourself in DEET when you're going out into those environments. That's not good for if there was a thermal exposure. Now, soil garments. Always get this question. What if my garments are stained, Derek? Staining in and of itself does not mean that the FR properties are compromised. Staining from an accelerant, if it smells like an accelerant, it's still an accelerant. That includes after laundering. If you come out of the washer, come out of the dryer, if it comes back from somewhere and it still smells like fuel, ladies and gentlemen, it is fuel. It will remain fuel until that fuel smell is gone. Either wash it until it's gone. If you can't get rid of it, get rid of the garment. Pretty simple that way. So again, staining here, 2 examples. Now, if this is after cleaning and there's no odor, both these garments are fine. The FR properties are still intact. They will both perform equally, assuming that they're the same fabric, same measurements, all that fun stuff. If this is during my workday and the staining on the left or the discoloration on the left is from secondary accelerants, I do not want to be in the hazard. Get me out of the hazard. That is way too much secondary accelerant. Get me changed out of that clothing or get me away from the hazard, one or the other. We can't work pristine. The one on the right, if that's secondary accelerant, since there was a thermal event, that fuel will be used. You will create what we call hot spots. There'll be small flare-ups as that fuel is consumed, and then the FR fabrics are going to do their job. So we can't avoid everything, obviously, but we can definitely apply some common sense. The one on the left is too much, and the one on the right is probably going to be, I'm probably going to be okay with throughout the workday based on what I'm comfortable with. Repairing or replacing. Yes, you can repair this stuff. Should you repair it? That's a completely different question. So let's deal with can you? Yes, you can. The rule of thumb from most manufacturers are size of a nickel for a hole and 3 inches or less in a rip. Aramid threads or FR threads have to be used in like material. So keep a couple of those old shirts and pants if you're going to use them for patches, and go online, Google Aramid thread, Nomex thread, flame-resistant thread, and get yourself a spool of Aramid thread, and you can make your own home repairs. Should you? It's PPE. It's a life-saving piece of equipment. The integrity of that garment is going to respond to that thermal event depending on how good the integrity is. I tend to use the analogy, hey, I look at fall protection. I don't have rips, tears, frays, or anything like that on my fall protection. I always wear my fall protection correctly. I don't leave my D-ring unmaintained. I'm checking all my stuff. My anchors are tight. I'm snug when I'm wearing it. I look at my FRCs the same way. No rips, no tears, get new ones. That's just Derek's opinion on that piece, but yeah, you can fix them if you choose to do so. We even tell you here in the tip section, hold on to some of those old garments that you've retired and use them for patches, etc. How much is too much? We don't tell you. I mean, you could technically, sewing and patching these things, but do you want to, risk serious burn injury because you're going to have failures on the integrity of that garment? Again, just things to think about. Here's some quick pictorial examples here. Look at the elbows. That's thread-borne. That's sprayed through. That is the secondary layer that's gotten into. You can see that. That's unrepairable. Replace it. Now, the one on the right, you've got a tear that's obviously over 3 inches, but it's on the seam. Can you repair it? Technically, I guess you could. It's on the seam. Do you want to? And you're making a decision on your life-saving piece of equipment. The one on the shoulder there, arguably that's within 3 inches. It's on the seam. Probably could make that repair. We'll get a couple more minutes here, couple things that just give you something to take home here, and then we'll open it up for some questions. For those who have flame-resistant arc-weighted clothing programs, if your people are out in the elements, just, again, stuff to think about. If you have rain gear as part of your program, if you have high-vis reflective vests, ANSI-compliant vests, ANSI-compliant rain gear, some things to think about. Take a note to go and look at the labels of both your rain gear and your ANSI-compliant reflective vests. And here's why. There is a lot of rain gear and a lot of vests out in the marketplace that have been marketed to you as flame resistant. The problem is they are flame resistant based on very, very minimal standards, and in very many cases they are not flame resistant to your hazard. They have not been tested in an arc flash or a flash fire, and you have no idea how they're going to perform. Here's an example. ASTM 2302. Now, understand these next examples I'm giving you are standalone in your label. You'll look at your label and you'll see FR based on just one standard. There's only one standard reference. 2302, 6413, we utilize when we are building towards a compliant garment. These are steps in the flame resistance process, and we utilize those. All top folks do, but we don't ever have them as a standalone, because here's why. One, 2302 is heat resistant, flame resistant. But it tells you right in the standard, not for arc flash and not for flash fire, not for high intensity heat nor open flame. It tells you right there in the standard. So how can you market that as flame resistant, and especially into oil and gas and electric? That's big in part the reason that they withdrew this standard and have temporarily got it sitting on the shelf, because it's been so misused, and they're actually going to rewrite it and do it properly, because people have been misusing that standard to market rain gear and vests into the FR world. And that'll be the only standard on the label, so be cautious of that one. The other one that they utilize a lot is ASTM 6413. That's your vertical flame test. That's where you expose a fabric for 12 seconds. It has to self-extinguish in less than 2 seconds. There can be a char length of 4 to 6 seconds, depending on the standard. That's all good. That is a jumping off. That is a jumping off point to continue further testing. But as a standalone, you have no idea how that rainwear or that vest is going to perform in an arc flash or flash fire. It's not a performance standard. The last one that we see a lot of is you'll have rain gear and vests marketed as FR, and the only standard that's letting them do that is NFPA 701. I'll say meets NFPA 701. Ladies and gentlemen, that's not even a garment standard. It's a drapery linen standard, and it's designed for commercial drapes and linens in the hospitality industry. It's a fire retardant chemistry that goes on there to slow the combustions of these huge draperies and these potential linens, so I can get from the 12th floor to the parking lot in safety. It's nothing to do with garment performance. So be very cautious. If you go and research your rain gear and your vests, and these are the standalones that are claiming FR properties, please don't implement them in the field. The ones you should be looking for our rain gear, it's ASTM 1891 for arc flash and ASTM 2733 for flash fire. Preferably have both standards in your rain gear, and then you don't have to worry about, if you have both hazards on your facility, grabbing the wrong rain gear. The other easy indicator is if you spent $100 on your if you go to your last PO on rain gear and each piece of rain gear was $100, you got the wrong rain gear. Rain gear for our hazards and what we're looking to protect against are typically between $400 and $500. That's the downside. For our vests, ANSI tells you for an ANSI vest to be FR, it has to meet one of 5 standards. ASTM 1506 is the most common. ASTM 2733, ASTM 1891. NFPA 1977, that's our wildland standard, and then NFPA 2112. So those are the 5 that ANSI has said you're allowed to market as FR. If it's not one of those 5, you have to say in the label that it's non-FR. So be very, very cautious as you're looking at that. So just in wrapping up here real quick, if I get asked, Derek, what are the things that I should do as an end user when I'm looking at my program? First, foremost, ask for the manufacturer's guarantee in writing on letterhead and signed. Make sure that guarantee is for the life of the garment. Guaranteeing to a hazard is not a guarantee, or guaranteeing to a standard is not a guarantee. If it says it meets ASTM 1506 or it meets NFPA 70E, or if it meets 2112, not good enough by any means. Make sure it's for the life of that garment, on letterhead, in writing, and signed. Get the data. The data is really easy to come by. All your top manufacturers, fabric guys should be able to get that to you relatively simply. Once you get those test data, verify them. Get a hold of the testing organization and just verify that what they're stating is indeed accurate. Can you imagine that people may mislead, may change documents? Don't be surprised. I've seen it happen. Specify that only compliant garments are on your job site, especially when you're working with contractors. Work with proven supply chain partners. Remember, everybody's good if you aren't in an arc flash or a flash fire. If you save $70 on a garment, great, good for you. When are you going to notice where you save $70 in the hazard? Okay? We build this stuff to be used in arc flashes and flash fires, hoping you never need to use it for what I built it for. But if all the bells and whistles aren't there when you need it, trust me, you're not going to be able to go get them. There is a difference. Buy quality stuff from proven supply chain partners. And then periodically police your program for compliance. It doesn't take long with some changes, getting distracted, a lot of stuff on our plate. That stuff gets added to programs that may or may not be what you ultimately wanted as your end goal. So periodically police that program. So with that being said, we've got, I think, about 10 or so minutes here for some questions. As Alan said, if we don't get to all your questions today, the fine folks here send me all the questions at some point, and I will make sure that if I didn't get to your question, you will get an answer from me via email at some point. So with that, I'm going to turn it back over to Alan.
Thank you very much, Derek, for your excellent insights and expertise. Before we start the Q&A, I want to remind everyone of the evaluation survey we're asking you to complete. The survey should be appearing on your screen now. Your input is important because it will help us improve our future webcast. If you do not see the evaluation survey on your screen, please turn off your pop-up blocker. You may also access the survey by clicking the survey button near the lower right part of your screen. As a reminder, to ask a question, you can type it in the text box in the lower left-hand corner and click the button for Submit Questions. Okay, so for our first question, can we use non-FR company logos on our FR garments?
Great question. And the easy answer is yes. But there are some limitations. Our standards typically tell us to keep it to a minimum. NFPA 2112 and 2113 have given us some square inch requirements. ASTM 1506 tells us from an arc flash standpoint, keep it to a minimum. What is a minimum? Think of business card size, your direct embroidery, your company name, the traditional, what the industrial launders refer to as R1, R2, those typical company patches. That size is what's a minimum. If you want to put a flag on the shoulder, if you want to put someone's, certification or something on the shoulders, you're probably okay. Getting beyond that, then you're starting to, from a non-FR standpoint, it would start to get questionable. They really want you to avoid big back patches, big pieces of identification that are non-FR, because you're going to have something that could potentially ignite and burning on FR clothing, then that energy is going to go in and cause injury to the wearer. So they want to minimize that. But small applications, that business card size, strategically located, all the standards say that that's allowable.
Does FR material have a lifespan, and what is that typically?
Another real solid question. What happens is, over time, over years ago, now we're going back, even before my time, when you go back to the FR greens, when you go back to in the steel mills in the 70s, there was a time when FR cottons had what people refer to as a treatment, and that treatment did wear out. The steel industry didn't care. It would wear out in about 6 months. They wore it out in about 3, so it didn't matter. When the technology and the engineering changed in the late 80s, early 90s, and this is why I talk about look for proven supply chain partners, all the technology utilized today in North America and coming from North American supply chain partners, you can have ultimate confidence that those flame-resistant properties are going to be for the life of that garment. When we get out of this hemisphere, that becomes somewhat, what's the correct term to use? That's somewhat not as strong. I wouldn't be looking at it as a strong, but if you stay within this hemisphere, regardless of the FR engineering, whether that's what you traditionally think of as the treated cottons into the FR motocrylics, which are engineered at the fiber level, into the Nomexes that have traditionally been at the molecular level where they tweak them, all the FR engineering where you impart the ability to self-extinguish, and that's ultimately what the definition of FR is, self-extinguishing. The technologies utilized by the top manufacturers here in the United States with the U.S. North American supply chain are going to be for the life of that garment, and that's what's key. They can't be washed out. They can't be altered unless you do something extreme to it, like we talked about in the care and maintenance. You're going to have those FR properties for the life of that garment, and that's what's important.
Our next question, can you explain how to figure out the layering if you're not supposed to add the cal rating?
So, tough question because it's going to take a little bit of time to answer because there is no easy way. And they took that easy way out a number of years ago where when we had very, very few fibers and fabrics available, when you had probably 5, you had, Nomex, Kermel, PBI, and Endura Ultrasoft and Endura. Those were your core fabrics in the world. We knew pretty much however you wanted to combine those, we knew that if worst case scenario, if you just added them together, you were going to be at least that. Now, most of the time you were going to be more, but you could at least tell someone you're going to be at least that. You can't do that today because of all the different fiber combinations, all the different fibers that are entering in that have FR properties, their pros, their cons, their strengths, their weaknesses. Long-winded way of saying, in order to know how that will perform, you have to get it tested because it's not as simple as 8 and 6 being 14. Sometimes we see 8 and 6 being 10. So we cannot tell you categorically that you'll always be the sum or better. And that's what has caused this need to get everything tested. So, for example, Bulwark on Bulwark, we've got 150 different combinations. My counterparts at all the other top manufacturers probably have, as many or close to it of their combinations. The tough thing is when you start mixing and matching manufacturers, what is that combination? Well, if you can get some third-party folks to help you, Hugh Hoagland at eHazard has done a great job on what all his testing he's done at Connectrix. There are resources out there, but I wish I could tell you we could go back to that because it would make everybody's life easier. Unfortunately, because the way the marketplace has evolved over time, it can't do that.
Our next question, we're required to have a 2112 label, but our clothes do not. But our vendor told us they are compliant. Is that typical?
I missed the first part of that question, Alan. What was that?
Oh, I said we're required to have a 2112 label, but our clothes do not. But our vendor told us they are compliant. Is that typical?
That's not typical. Especially in today's world, if you are 2112 compliant, that means you've went to the expense of having an independent third party verify not just your fabrics, but everything that goes into making that garment, which are your findings, and also have audited your facilities. So fabrics finding its facilities equals certification, and a third party monitors that. So if you went to that expense to indeed have independently certified 2112 compliant garments, you label it. So I find it very hard that if they've indeed achieved that they would not label it. I'm not saying that it's outside the possibility, but that is something as a manufacturer we take great pride in having done, and we definitely want to communicate that to our end users that they are indeed wearing garments that are compliant to their hazard based on today's standards. So it's not the norm.
Our last question, where can you find an FR belt?
Okay, FR belts. They're not readily available. I don't know of anything that is truly an FR belt. So here's what the kind of rule of thumb is. Leather, very resistant to heat in general. You'll see some shrinkage. You'll see some turning over. If the fabric in and around it does not ignite and continue to burn, leather is going to be fine. Even some of our very, very thick ballistic nylons, when they're in thermal events, because these are short duration thermal events, we see very, very little impact on high density nylon webbing type belts. So leather is just like leather footwear, leather belts, leather gloves as our outer protectors. They hold up well in these short duration thermal events. Where your concern would be things like shrinkage, things like melting, dripping. Leather doesn't do that. So again, as a natural element, you're taking that out of the equation. So I don't know of anybody who's marketing something as flame resistant. We do see some use the term it's arc resistant. That tends to be just a heavyweight leather belt. We've seen some of our fall harnesses, which use those ballistic nylons and those heavy-duty nylons. We see those being arc resistant to where they're tested, and they still have to perform after an arc flash exposure. That webbing still has to have X amount of foot-pounds of strength left over because I'm going to be dangling from it. So we do see those types of materials. So if you would have a belt made out of leather or those high-intensity ballistic nylons, they're going to hold up, and they're not going to cause injury, and that's what we're looking at the end of the day. Do we transfer injury from that waistline based on that leather or ballistic nylon? To me, the wear.
All right, thank you, everyone. Unfortunately, we have run out of time. I'm sorry we didn't get to everyone's questions, but as mentioned earlier, all of today's unanswered questions will be forwarded to our speaker. Once again, I hope you take the time to fill out the evaluation survey on your screen to give us your feedback. That ends today's Safety and Health Magazine webcast. I'd like to thank Derek Sang, everyone at Bulwark, and, of course, all of our listeners. Have a safe day.